All right, welcome everyone. Today's stream is going to be on automating with Ansible and some of the pitfalls you might run into. So, one of the things I've been doing is going through different network operating systems and figuring out is like the experience the same that I've had on Arista, because I've got quite a bit of experience with automating Arista gear. Is it the same with the other network operating systems? And I'm finding that's not the case, at least with the Ansible. Now, this does not appear to be Juniper's fault at all. It's just the way that the modules are. And so let me see if the stream is up and everything can hear me. Now, this does not appear. Okay, looks like we're good. Okay, so these are pitfalls that you might run into if you are going to be automating Juniper. So in my environment, I've got a small topology here. I'm using Juniper vSwitch. And I'm using that because I thought that's what you needed in order to do like EVP and VXLAN. And I was going to try to play and build a multi-vendor fabric. But the problem is it's a virtual machine and not a container. So I'm using Container Lab, and the way that it works it uses a project called the AirNet Lab. So it takes that image and puts it into a container and then runs a VM inside of the container, and then you run that in Container Lab. It works. The only problem is it uses up a lot more resources than a normal containerized device would. It turns out there's also, was it CRPD from Juniper? And that might fit the bill, but you can't download that just off the website. You can with the Juniper vSwitch, oddly enough, and I think some of the other virtual machine images. But they restrict access to the container, and you need an account, and it can't be like a Yahoo or Gmail account. So I applied for one. I haven't gotten any notifications back whether or not they've accepted it. So I can't download that image yet. I might not be able to at all. We'll have to see. So I'm just still using the vSwitch from Juniper, which you can get and download it for free and use it in a lab environment. So that's what I did. And then I've got one Arista device, and I got two Juniper devices. One's acting as the spine, and one's acting as a leaf. And once I figure out if I can run that container image, then I might update the topology to include different types of vendors other than just Arista. But we'll have to see. The reason why I like Arista is, one, I'm familiar with Arista, and they have a really great containerized EOS. They only have one network operating system, EOS, and then there's a flavor of it for VMs, and then there's a flavor of it for containers. And it has almost all of the features that it's been like that for a while, where it's had almost all of the features, even in the containerized version, that you get in the physical version, with some exceptions that would like normally be hardware specific, like QoS. You can't do multiple queues, that kind of thing. So I'm just playing around in here, and I did notice some interesting things, a couple of things about running some playbooks. So let's go into, so I'm in my environment here, and let's log into one of the leaves. Let's go to the spine. And it had been a long time since I'd used Juniper, and it was like 10 or 15 years ago. I never really used it day to day. So I'd playing around. I was doing some tech field day stuff a while ago, and got some really interesting, presentations. There was one set of tech field day events where every vendor was talking about basically the same problem, and they were really starting with automation. But the automation world back then looked a lot different than it did now. A lot of on-box automation, on-box Python scripts, that kind of thing, and we've really moved away from that. So, but anyway, so I wanted to start by building an underlay between the leaves and spines, which I would use OSPF because that's the simplest one to do. And still also finding my footing in Junos. And I ran into two problems. Number one, I found a bug in the Junos Ansible modules. And then two, so I'll show you the issues. Number one, OSPF interfaces bug. It doesn't render interface type. So between, I'm going to run OSPF, and initially I did numbered, and the module to assign the IP addresses to the interfaces worked. It worked for Arista, and it worked for Junos. And I could assign IP addresses. And then I tried on the EOS device, on the Arista device, I made it network type point-to-point, which, if you're familiar with OSPF, if you do point-to-point, it means there's just going to be two ends, two routers, one router on one end, one router on the other. There's not a shared medium where you might have to elect a designated router and a backup designated router. You just establish a neighbor relationship. And there was a... If we look at the documentation for Ansible, so we'll do Ansible, Junos, OSPF. So this is the OSPF interfaces module. It's a little confusing because there are actually several modules for OSPF. There's OSPF version 2 and OSPF interfaces. So you basically just need this one. But there is a parameter. So in any given playbook, let's take a look at our parameters. In any given playbook, there are a module that you're calling. In this case, we're calling the Juniper networks, Junos OSPF interfaces. And it needs parameters. And it's going to vary from module to module. Now, fortunately, between vendor and vendor, like there's a similar module for Arista and for Cisco, et cetera. And they're mostly the same. A couple of differences, but one of the parameters is interface type. I want to set this as a point-to-point interface, and it's not doing it. It's taking the value and it's not doing anything with that value. And so when I apply this playbook to the devices, it doesn't set the interface type to point-to-point. It just leaves it as the default. And we can see, so let's go into config mode in Arista. So this is on the spine. You can see here that these are the two interfaces. This one goes to leaf 1, which is EOS. This one goes to leaf 2. And so we're going to do protocol, or we're going to do delete protocols, OSPF, area 0, interface 0, and we'll just delete that. And then we'll do, let's delete the other one too. And then we'll do commit and quit. Taken a little while to get used to this CLI that, again, I haven't really used for years, and again never constantly. It's an interesting mix because this is the native configuration syntax, but instead of editing it directly, you issue these set and delete commands, which is totally forgot about that. So let's do show config, and then we see that for protocol OSPF, all we have is loopback 0 configured. So let's run this playbook, and I have interface type P2P, and I will run it. Ansible playbook, playbooks, configure underlay. So another interesting thing is that the playbooks for Junos take a lot longer than they do for EOS. Now, part of that is the confirm commit part. So you can make an argument that it's what is it not like here? Oh yeah, so this is another problem. You can't set unnumbered. So I'm going to take that out. There's no way to set an interface for unnumbered in the interfaces section. So we'll just, I won't take that either. So I'm just going to comment those out so it doesn't try to configure them. So it won't be streaming for a little while. We tried P2P with single quotes in the, hey Wilson. Have you tried single quotes? I have, but the problem is not how it is. I'll show you. It doesn't even render. It doesn't even try to do anything. It's not giving me an error. As you'll see here, it configured the L3 interfaces on the spine. Now it's going to configure OSPF. It's going to do it. And then you can see here, this is the actual, in Juniper, the API that Ansible uses. Every different vendor has different APIs that are available to it. In Juniper, it's only netconf. And here is the actual netconf. Here's the actual netconf rendered, and you can see that it's not even trying to set point-to-point. So it didn't give me an error on the output, and it didn't even try to set that in Junos. So if we go into the spine, we do show config. So Wilson helped me out on my last Juniper live stream. You see that we've got, so these were already configured. Yeah, so it didn't even try for P2P. I'll go ahead and try the, put it in quotes. I mean, maybe, who knows? I'll keep it consistent with, generally it doesn't matter if you do single quotes or double quotes, but it is good to be consistent. Otherwise, it can get a little annoying. So we'll try that again. So we'll see if maybe this will fix it, and then I'll feel silly, but we'll try it. And I did open an issue. I did open a ticket in GitHub, and oddly enough, these Ansible collections are not run by. So Juniper OS, this is not run by Juniper. It's run by Red Hat. I believe this is run by Red Hat. The EOS ones, the EOS collection is actually maintained by Red Hat. So I think this is, yeah, Ansible collections. Let's see if the people that worked on it. Yeah, Red Hat. That may be part of the problem. I'm guessing Red Hat's trying to get the people to, get the vendors to start maintaining their own stuff. All right, so it did it, and it shows no changes. So nothing on the config actually got changed, and we'll just double check to make sure. Show config. Yeah, so it doesn't have the point-to-point in there, and you'll get some. I want to do a point-to-point because that's the best practice if we actually have a point-to-point link. So we can't do it that way, at least until this gets fixed. Another problem was that the other problem I ran into is if I'm going to do, if I'm going to lab a BGP, EVPN, VXLAN setup, I try to do IP unnumbered just to keep me from having to assign IP addresses. So I like IP unnumbered, and I like using OSPF as the underlay because it's so simple. There's very few knobs you have to turn, Whereas if you do BGP, part of the BGP config is going to be for the overlay and part of it's going to be for the underlay. And I really like having the separation. So if I'm looking at BGP, it's only going to be for EVPN, and it's not going to be for like just simple IP routing for the underlay. So, and then to keep it again as to keep it as simple as possible. I'm just gonna I use OSPF as the underlay and IPN number and so forth. So I'm trying to do that with Juniper, and Juniper can do it, but I've run into a couple issues with Ansible. Now I have run into issues with the collections for EOS. In fact, I opened 2. And Red Hat fixed them both. So I found them in 2021. One of them was SSH keys not working in EOS user, and then it wasn't deleting IP addresses from interfaces. So I was able to open them up, and they were both fixed. It took about 2 weeks in both cases for it to get fixed. This one, I haven't even gotten it has not even been assigned yet, so I don't think anyone's even looked at it. But I try to put as much documentation as I could, including the rendered output for the netconf. Oh, thank you, Tristan. Tristan says, said my videos are more popular. Oh, yeah. Thank you. Are you talking about the ones I did for packet pushers? I'm working on a course for troubleshooting EVP and VXLAN because I don't think the vendors do a very good job of covering that. And I'll see where I can put that. I also won't be streaming for for a week or so, as I will be on a skydiving trip. So I'm going down to Southern California to a town called Paris, California, to do some big wave. So big wave is when lots of skydivers jump out of multiple airplanes. We're doing anywhere between 100 to 120 jumpers. And so I'll be one of those 120 skydivers. Okay. I can't do IP unnumbered here. So I've got, there's a couple options here. I can just give commands. So with Junos, they're like you notice there's no VXLAN section, and EOS doesn't have a VXLAN section either. You can always just give it like raw commands. So I can do that. It kind of defeats the purpose though. Why use Ansible if I'm just going to issue commands? So I can do these style commands. So here, so rather than configure IP addresses this way for leaf 2, well, I'll let it configure the loopback. So what we need is indentation, name. Something got messed up in the indentation here. Yeah. Yep, more indentation. There we go. Okay. This is also something where we get into a problem with the playbooks start to get really big, and it might make sense to start to break it up into smaller pieces. But I want to configure the underlay for at least the Juniper devices. So spine 1, we're going to allow it to configure the loopback interface, because it does have an IP address, using the L3 interfaces module, which does work. I haven't tried deleting them, so maybe it has the same bug that I had in EOS. So that would be interesting. Oh, Trista did Arista L3 trading from Sunset. Oh, I didn't know they did L3. When did you take that training? And was it Arista courseware? Or was it Sunset courseware? All right, so we've got L3 interfaces. We're going to do that. We're going to configure that, and then I have to configure the point-to-point links. Configure point-to-point links via commands. So I just need to. So it'll be figure out what the set protocols. No, set interfaces. Oh, config mode. Set interfaces. To look at the setup interfaces. GE. So 0. Unit 0. Family. INET. And unnumbered address LO0. So I think that's the command, if I remember correctly. So we're just going to do that, spit that out, and then spit that out again for the other interface. So that's 1. So it's just going to do those, spit out those raw commands, and that will configure the IP unnumbered. And then we'll have to do the same thing with set protocol, OSPF, area 0, interface GE00, and interface type point-to-point. Yeah, I could use show configure and display set. For some reason, I like the yeah. So what he said, what Wilson said is I could do show configuration, and then run show configuration. It's like the do like in iOS you can't do a show run when you're in config mode, which really annoys me. I really hate that about iOS. In NXOS, you don't have to do that. You can just type in show run even if you're in config mode. Same thing for Arista EOS. But in Junos, it looks like it does the same kind of thing. If I want to do a show run, show config, then I have to do show config, and then I can do display set, which will take this structured configuration, and it will show it in the set command. So that would help that. So that would be a little shortcut for that. So I could just figure out what to put in there. So thank you for that. So we're going to talk about that configuration syntax in a minute here. So set interfaces, unnumbered loopback 0, so it's .0. So that's what it is there. So that already has to exist, so it does. So we have to be careful about order of operations when we're doing this kind of thing. And then configure OSPF. I could leave just the LO part because that does work. It does set it as passive, but I don't like doing configuring it in two different places. So I'm just going to replace this entirely with a config thing, and I think I probably should put it. For OSPF, I probably should put it all in the same line, because otherwise if I run the module twice, it's going to take twice as long. And like I said, Junos, it takes a little while for Ansible to run against it, much longer than it does for EOS. Now again, part of that's for commit, and some of it may be just because of the virtualized nature of this. I'm not exactly sure what the delay is. Arista show active. It's interesting how they, the different vendors have different ways of displaying the config. Like in Arista, if you do a show run, you'll see the iOS style syntax that's native to EOS. That's the native configuration syntax. And with Junos, this is the native configuration syntax. This right here. So this is structured, and then we can do loosely structured by doing the display set. In EOS, you can output it through JSON. You can get a JSON representation of the config. In NXOS, you can do XML and get an XML representation of the config. So if you want the structured output, you can get that. Or even if you're in a show command, you can pipe them through JSON or XML respectively and get structured output. Can you do that here? I think you can do, XML, and then let's see if they can do JSON. You can do JSON, and then let's see if it'll do YAML rather. Nope, no YAML. Yang? Nope, no Yang. Okay. All right, so do show, run show config display set. So I'll get the protocol part. Yeah, so we'll just go ahead and just blast them all out at once. So I don't like doing it this way. This is we call this this would be so if we do it this way, it's declarative, and then if we do it this way, it's imperative. So we're not telling it the idea of what we want. We're telling it exactly what to do. I generally don't like doing this. There's another way that we'll talk about. But here we go. So this should do it, and then I can just get rid of this. Unfortunately, because I'd rather do it the other way. Okay, there's no what is it set set protocols OSPF? Is there a router ID? How does it find out it does have a router ID. I just don't know how it sets it. It picked loopback 0, but I don't know if there's a way to override that. I mean, I would imagine there is. Let's do, we'll just Google it. Configure router ID Junos. OSPF, because you do the same thing. And I've noticed some interesting gaps in some of the documentation for Junos. Arista has some gaps too, but there was a whole section on how to configure point-to-point interfaces in Junos in one of the documentation pages, and it actually didn't have the command in there. So it talked about it, but it didn't show the command. It showed the other commands, but it was missing the actual command. Router ID. Configuring an OSPF router identifier. Instances. Oh no, that's set routing options. Does it do it for all routing protocols? That's a good question. So I'm going to pop that in there too. It had been selecting this loopback 0 as the routing ID, even though I hadn't set it. But for router IDs, you always want to set it. I've run into issues. One of the troubleshooting things I had to do with EVP and VXLAN is I was running OSPF as the underlay, and then 2 devices had the same router ID, and that causes all sorts of problems. So, yeah. So Wilson, so you asked where can you learn Arista? If you take, if you go to GitHub, at least for the lab environment, I don't have the like lesson plans or anything for you, but if you go to GitHub and you go to my name, Tony Burke, there's a thing called Project Nerd. And what it is a set of instructions on how to build yourself a virtual machine. And it's got everything you need in that virtual machine to run this topology with containerized EOS. So if you can make a virtual machine with 4 virtual CPUs, 16 gigs of RAM, and 60 gigs of storage, which I think most people can do, even on a laptop, maybe not a laptop, because 16 gigs is kind of a lot, you can build this topology, and I've got all the instructions on how to build that VM. And in fact, this is what I'm using. I just have a different topology in it. So all of this is it's a Linux box. Other than the Junos topology that I've got here, this will tell you how to do it, and you can build yourself a little lab. Yeah, and the Arista images are free for learning. The only trick is, just like Juniper, to register you can't use a Gmail or Yahoo or one of those accounts. You have to have like a corporate-ish account, but you get accepted immediately, and then you can just download the containerized or vEOS labs. So there's CEOS lab and vEOS lab. You can get them for free, and you can use them for a lab environment. So Project Nerd, I'll put it in the chat. Okay. So let's try this. Comment, update, config. Oh, forget about the render part. Just going to spit out raw syntax. I can get rid of this. On this, I need to... Yep, unfortunately I have to do the same thing for the... I don't want to... Well, let's leave it and see what happens. So I'll let the interfaces module configure loopback 0, but we got to configure everything else via this. Completely replacing all this stuff. So we're just spitting out commands. We don't have a there. That's fine. We don't have an Ethernet 1, and our router ID is going to be just 1. Oh, I'm sorry, .2. Where's .11? Another interesting thing about, it was .1, so this will be .2. Another interesting thing about using the vSwitch VM in Container Lab is it doesn't save the config when you destroy and deploy. So you shut it down and then you deploy, and the config's not saved. So it's kind of a bump. It's a little annoying, but I mean, we're automators, so that's what we want. So let's go ahead and commit and quit. Another thing it takes getting used to is some of these require. Sometimes when you reference an interface, you have to put a .0 after it, and sometimes you don't. I haven't quite gotten used to which time is which. All right, so that I think that fixed the problem. So I got to make sure I fix it in the. Yeah, that looks like it's good. All right, so let's run that playbook again. I got an indentation problem. Unexpected parameter. Doesn't like something about this. Tasks name. So this is one playbook with two plays, because one play is running against spine 1 and one play is running against leaf 2. Did I? Oh yeah, missing a parameter config. That's what it was. You can see it's taking a little while. Okay, so it didn't like something rendered out. Oh yeah, it did the rendered output stuff. I don't need to print that out because I didn't actually do this. So fun fact about YAML, it doesn't like to have the last line have text in it. It wants a blank last line. So if you see the last line have a linting issue, that's because it wants a blank last line. And if you have a couple spaces in it, it'll still give you an issue. So you have to just have one blank line with nothing in it. So this is not something you'd want to do in a serial fashion. You want to make sure that you're running your playlist against all the devices, or as many devices as you can at the same time. Otherwise, it's going to take forever. Okay, so we're good there. Let's just go to the spine. And then do a show routes. Grab OSPF. Show OSPF neighbors. Nothing. Show config. Oh, because I forgot to put the point-to-point part in. I keep saying enable, so config mode. And we want protocols. OSPF. Oh, set protocols. OSPF. Area 0. Interface. Interface type, point to point. All right, so I'll just take this. What was the whole point about doing this? Oh, I forgot to do it. Now, do I need to, the question is, let's do a commit and, do I need to do it twice? Do I need to set it in multiple lines? I don't remember. So it's always a good idea to do something manually before you automate it. Config display set. Nope, you just have to do it once. Okay. So let me just do that. And that should get us a all right, run that. Yeah, Tristan, I'm glad you liked my videos. I'm glad they helped. I don't like the way that most vendors teach EVP and VXLAN. I teach it a different way. I like the layered approach. You start with the topology. So leaf spine, which is a 3-stage CLO, or super spines, which is a 5-stage CLO, or we call it multipod as well. And then you do the underlay, which is just getting loopbacks into the routing table. That's all you need, is just IP connectivity between the loopbacks. That's all you need to do with the underlay. And you can pick any routing protocol you want. And then you do the overlay, which is just EVP and overlay peering. So it's a different address type, address family. You peer between the loopbacks, loopback 0 typically. And then you have the EVP and services, which gets a little bit more complicated, but the first 3 parts, the 1, 2, 3, and 4, which is the topology, the underlay, and the overlay, is actually pretty simple. And then most of the magic happens in the EVP and services. So those are VRFs, L3 VNIs, L2 VNIs, Anycast gateways, that kind of thing. All right, so that was set. Let's see if we see neighbors. Okay, we got neighbors. Let's see if we got routes from OSPF, and we do. So we learned these are the 2 loopback addresses, one for leaf 1 and one for leaf 2. So that's good. Now, this is one way to do it. I kind of don't like it. I don't like just shooting commands, although it works. The other way is to replace the configuration entirely. So Junos, like Arista, like Cisco with iOS and NXOS, are what's known as single configuration file devices. The entire configuration is loaded up from one file. So all the config state is in one place. And here we can see it. The native configuration syntax is this. It's kind of like JSON. It's kind of like C. It's its own thing, really. It's a Junos config file. This is the native configuration syntax for Junos. This is what Junos loads up when it boots up to see what the configuration state's going to be. And we can do a full replacement of this. And by doing so, I made a template here that will build a new config and deploy it to each Junos device based off of different parameters. And we get these parameters from GroupVar. So this is a data model that I made. It's a homemade data model. It's in YAML, so it's really easy to read. And you can see here we've got devices. We've got 2 devices for Junos. Junos Leaf 2 and Junos Spine 1. It has the links that are point-to-point, so that we know we're going to set some parameters for these point-to-point links. We know we're going to set them as IP unnumbered. We know we're going to set them as point-to-point in OSPF. The loopbacks, we know we're going to configure those, and we know we're going to do those for passive for OSPF. Here's the point-to-point loopback that we're going to use. Whenever you do IPN numbered for IPv4, you have to specify a loopback address to pull that address from. Point-to-point MTU, but we're not using that in an area, which we do use. And so my template here, for example, this starts our protocol OSPF for area, whatever this value is in that file we just looked at. And then it loops through each interface in the point-to-point section of the YAML, and then builds that config, and it'll build it. Wilson, there is no course right now that has the way that I teach it. Unfortunately, I might make one. It depends on a couple of things that's going on right now. Like Arista, they've got an L3 course. L3, that's where you learn EVP and VXLAN is L3. It's not me in the videos. It's someone else. And sometimes I teach it. And when I teach it in person, I teach it that way, the 4 levels. And but the videos that are on there are someone, I don't remember whose videos those are, but they teach it a different way. It's me, if you take the L5 course from Arista, level 5, that's the automation course. Level 4 is service provider, so MPLS mostly. And then I'm level 7 certified, which is like the highest level. It's kind of the CCIE of Arista, but it's not very common. All right, so yeah, I really like Jinja templates because now this becomes my source of truth, and then we just render a new config. You know, we just render a configuration every time. So, for example, I'm gonna take out this configuration. So this will not configure the point-to-point link for the second interface, GE001. So I'm going to... What happened to all my terminals? I'm going to do build config. So it runs the playbook, and then it builds out a new version of the config file. So for the spine right now, we only have one interface configured for OSPF and one interface configured for the loopback. Interfaces, the IPN numbered. So I'm going to run deploy, and it's going to push those configs, one for spine 1 and one for leaf 2, because the playbook, we are loading, we're going to update the config, and we're going to override the config. So whatever was on there is going to go away. Oh, Wilson, yeah. So there was a someone from the Packet Pushers. I wish I could remember his name because he was really helpful. There was a command. Turns out Arista does not follow the RFC for IPN numbered, and does a weird hello packet. And there's a command to reverse that, and I'll show you what that is. It wasn't Junos. So that took a little while. Let's see. Okay, so we still have, so this is the configure, this is the OSPF config to the Arista device. We didn't kill that one. It's been up for 34 seconds. So let's redo the config. We're gonna change the data model. Oh yeah, I want to show you real quick what the command is on the Arista. Interface, unnumbered, hello mask, transmit 000. That's it. That's the only thing you needed to do. And there's an article by that Ivan Pepelnyak did that covered this same thing, but it wasn't that article that fixed it. Well, the article shows how to fix it, but it was someone on Packet Pushers who was like, I was like, I don't think this is a. There's a Packet Pusher Slack, which is good for just talking about this industry. And I was mentioning the problems, and I thought it might be an interoperability issue. What do you do if you're trying to build a fabric with more than one vendor, and there's something like that happens? Who do you open a ticket with? Probably both. And they're going to be reluctant to try to support you because it might be the other device. Maybe they just have a different interpretation of the RFC. Maybe they're just not doing the RFC right. Who knows? In this case, it was an easy fix. So I uncommented that out, and then the process is build. It's here. Do watch. Run watch. No, they don't have a watch command. Okay, show OSPF neighbors. Detail. All right, so let's go ahead and run this. We'll build the config. So now we got a new config. That happens real quick, and then we deploy that config. What I want to know is, does it reset the OSPF session? I hope it doesn't, because that would kind of suck if it did. It's going to take a while to deploy this. Wilson, do you know if Junos has a watch command? Okay, didn't reset the old adjacency, and the new one is up. So yeah. So those are some of the pitfalls you can run into when running Ansible. Trying to do these discrete modules is sometimes they just don't work, or sometimes they don't cover every case that you want. So it tells me that people probably don't use these modules very often, at least for Junos. I wonder how much it varies between vendor and how this works. So we either had to resort to doing set commands in Ansible, or we just rebuild the config and replace it. So if you have a network device that is a single configuration file device like Junos is, then you just replace that config. You just make a new one from a template, and then you upload it, and then you switch to it. And the nice thing is, because we're doing it that way, if I remove an interface and regenerate the config, it replaces the entire config, and now that interface is not configured anymore, versus us adding to it, but not if not deleting from it unless you explicitly delete. This implicitly deletes objects that are no longer in the data model. So this data model becomes our source of truth. This data model is the representation of our desired configuration state, and the method that we're using it will replace the configuration state. So it's getting late here, so I've got to run. But yeah, so thank you everyone for watching. This will be up on YouTube. I'll leave it up on there. I almost put this as part of the EVPN, or as not EVPN course. I almost put this up there as part of the automating network configuration with Ansible. I think I'm going to wait to see if I can get the containerized Junos working, and working enough to at least where I can do something like this. Because you can see, I'll show you, it eats up a lot more RAM and eats up a lot more CPU if you use the virtualized vSwitch instead of a containerized switch. So let's do sudo docker stats And so the EOS Leaf is running like 8% of the CPU, while the two Junoses are running like just eating up all of about 2 cores each. And then they're running 5.5 gigs of memory, and EOS is only using 2 gigs in this case. That's actually a lot. It usually doesn't use up that much. So you can't fit as many of these in there, and it kind of eats up spikes the CPU. So I'm going to go ahead and just sudo container lab destroy. And then if I do a deploy again, the Junos stuff is not saved. But I can always just redeploy it. Tristan says, I'm the original gangster of network automation. I'm an early adopter, but I'm not the OG. There's people that were doing more stuff even earlier than I was. Although I was doing server automation back in the 90s when I was writing like Perl scripts to do things. That's when I started. But anyway. All right, thank you. Thanks for everyone for watching. Thanks again, Wilson, for joining me, and thanks again for your help yesterday. That helped out a lot since I'm not very proficient on Junos, but I'm getting better. Thank you for watching. Have a good evening.